It doesn't come back up. Most underwater robots eventually have to come back to a ship. This one is being designed around a completely different idea. Send it down there and let it stay. Weeks, months, underwater. These machines can inspect equipment, monitor underwater infrastructure, and handle jobs that normally require ships and crews to reach. But eventually the battery dies, right? That's the part I wanted to understand, because the answer is basically, put the charger underwater too. It recharges down there? They're called resident underwater vehicles. And unlike the underwater drones that get launched for a mission and then recovered afterward, the whole point is for these robots to remain near the equipment they're responsible for monitoring. One real example is the ARV-i. It's designed to operate autonomously without a tether, inspect underwater environments, and return to its own docking station when its battery gets low. Once docked, it can recharge wirelessly and transfer the data it collected. Then it can head back out again. The company behind it says the system is designed to spend months submerged, with applications including industrial sites, reefs, and other underwater monitoring. And it's not the only machine heading in this direction. Saab Seaeye's Sabertooth has demonstrated remote deep-water docking for battery charging and data transfer, and a resident subsea program has been built around keeping one docked on the seabed between missions. Why go through all this trouble? Because working underwater gets expensive fast. If you need to inspect a pipeline or some piece of offshore equipment, traditionally you might need a vessel, crew, and remotely operated equipment just to get eyes on the problem. Now picture having the robot already down there. Something needs inspecting? Wake it up. Send the mission. Robot leaves the dock, collects images and sensor data, comes back, transfers everything, and starts charging. That's a completely different setup. Oceaneering is pursuing the same basic resident approach with its Freedom AUV and Liberty docking technology. Its resident system is intended to reduce vessel days and support remote operations, while Freedom can dock, recharge, offload data, and potentially change tools without being recovered to the surface. And this isn't only happening in controlled demonstrations. In 2026, researchers reported trials at about 90 meters underwater, where a robot autonomously performed inspection missions, returned to its docking station, and connected without human intervention to recharge and upload its data. Now think about where that could lead. Offshore wind farms, underwater cables, pipelines, ports, environmental monitoring. Instead of periodically sending humans and ships out to check infrastructure, networks of robots could eventually remain stationed near it. But living underwater isn't easy, even when you're a machine. Salt water is brutal on equipment. Currents push you around. Visibility can become terrible. Communications underwater are much harder than simply connecting to Wi-Fi. And docking autonomously when you can't clearly see the station? That's a serious robotics problem. The robot has to navigate back, locate the dock, line itself up, and connect successfully. Then the system needs to survive doing that again, and again, and again. That's why I think the charging station might actually be just as important as the robot. Because once an underwater machine can reliably return home, recharge, and redeploy without somebody hauling it onto a ship, you've removed one of the biggest reasons it needed humans nearby. We're used to robots working in factories, warehouses, even sidewalks. But resident underwater robots are pushing automation somewhere. Humans were never particularly good at living in the first place, and eventually, the strangest thing about finding a robot at the bottom of the ocean might be realizing it's been down there, working the entire time.